Before starting a simulation, you want to make sure that the design data is set up correctly. Using the reference designator mapping dialog box, you can make sure that all of the components on your board are correctly recognized. Next, you can tell the tool what nets are differential pairs. The tool can do this automatically for you based on your naming convention. Once this is done, you can assign models to your parts. There is more than one way to assign a model. One way is to use a .ref file to assign a model to a reference designator. In this example, we assign an IBIS model to U2. Another example is to assign a model to a part number. So for instance, if you have multiple DDR chips on your board, you can assign the same model to all of them at the same time. Lastly, you can assign models on individual pins. Selecting a net highlights that net by dimming the rest of the board. Here, we will make U2 the driver and U1 the receiver. Then, we will set up a coupling threshold. This is the level at which the noise from an aggressor is deemed to have a destructive effect on the victim net. Here, we will set it to 35 millivolts. With coupling enabled, you can see that nets that are coupled to the highlighted net are also highlighted. To run simulations using different process corners, we can use the Sweeps Manager. Here, we will enable all 3 process corners. Now we can see the results of the 3 different simulations and hover the mouse over a waveform if we need to know which process corner it represents. To analyze multiple nets, we can use the SI Batch Wizard. This allows us to run the termination wizard and crosstalk analysis in batch mode. To do this, we will simply select the nets we want to analyze. The best way to use this part of the tool is to run a quick analysis to estimate the crosstalk on a large number of nets in order to find the nets that may be problematic or that may fail. Then run a detailed analysis on the nets that may have issues. Quick analysis is only a general estimation, so it can be imprecise, but using it is very helpful to reduce overall simulation time. Detailed analysis, on the other hand, will produce extremely accurate results, but it has a longer simulation runtime. HyperLynx can also be used to perform what-if analysis. If you have a net that fails signal integrity tests, you can export it into LineSim to view the transmission line models for that net. Note that this circuit, which in theory should only have one transmission line, has many. This is because each trace segment is considered a separate transmission line. So in LineSim, you can change the transmission line lengths, models, and topology to see how such alterations may improve your design.